Let's talk about compounding continuously. When you see that phrase within a word problem, you need this specific formula in order to calculate how much money you would have after an investment at a certain rate and time. So our formula we use is A equals PE to the RT power. We call it the Pert formula because as you can see, it looks like it spells out the word Pert, like the shampoo. And A is the final amount, P is the initial amount, E is the button in your calculator, second natural log or anti-natural log, R is rate, and T is time. So it's set up a whole lot like the other formulas we've looked at with growth and decay and with interest. The A and the P and the R and the T. The only difference is the E right here. So let's just look at two examples of how you might use this formula. Now keep in mind, this formula is reserved for when you see the words compounding continuously or continuously compounded, but that specific phrase would need to be in the problem for you to need this formula. So for number one, it's the straightforward type of example. If you're given everything except for the final amount, you would do this. So if you invest $400 compounded continuously, how much will it be worth after 6 years at 3.75%? So I'm given everything except for the final amount. So I would plug in everything. P is the principal amount. So that's 400. E is going to be a button in my calculator, second natural log. Rate, I need to change to a decimal. So I make that 0.0375 by moving the decimal place over. Wait. Wrong way. Definitely the wrong way. So 0.0375, and we put that up here in the exponent and times it by t for years, which was 6. So I calculate that in my calculator, and I would come up with $500.93. So again, that's just the very straightforward kind. You have everything except for the final amount, and sometimes they just ask you questions like those. But what if they ask you something about rate or time and you have to solve for the R or the T value? You would do this. So at what rate would you need to invest $5,000 compounding continuously so that it will be worth $30,000 in 18 years? So this could be a parent that's going to invest $5,000 and try to make it become $30,000 for their child to go to college. Now, $30,000 these days is really not an awful lot, but it still would be a lot to get you started with. So it's a good example of that sort of thing. So if we were to invest this compounding continuously, the A in this case is going to be what it would end up as. So the A is the 30,000, and we can leave off the dollar sign. We don't need that while we're calculating. The initial amount, or principal, was 5,000. E, again, is always there. Nothing replaces the E. The rate is what we're looking for, and time was 18 years. So in this case, we need to get E by itself, because this is now an exponential equation. Because my variable is in my exponent, I'm going to need to solve it as an exponential equation, which we have already worked on. So we divide both sides by 5,000. We get 6 is equal to 18R. So notice that really shrunk very quickly to a little bitty equation. And then, or excuse me, we have the E. Whoop. Back up. That shrunk too far. We still have the E and then to the 18R power. All right. So then we can take the natural log of both sides to get rid of E. And remember, natural log has a base of E, so those just cancel out. And then the natural log of 6 I've already calculated is 1.79. And then you just need to divide both sides by 18. So you end up with R equals a decimal, 0.0995. So remember to move the decimal back over 2 places, which would be about 9.95% for our rate. You turn it back into a percent. So those are 2 examples of what you would see, and they cover pretty much any type of problem. You're either going to have to find the final amount or you're going to have to find rate and time, and either way would work very similar to this one.